1.5 is on segment lengths in a circle. So it says theorem, if two chords intersect inside the circle, we already talked about the angles. Do you guys remember how the angle, like this angle right here, we called angle 1, was half of the sum of these two intercepted arcs, right? Now we're going to talk about the segment lengths. So we're not going to talk about angles this time. But we're going to say that this piece, do you guys see what I'm highlighting? AE multiplied by EC ends up equaling BE times ED. So it says then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So in this case, AE multiplied by EC ends up being the same as BE multiplied by ED. It basically has to do with like similar triangles, if you set up proportions with those similar triangles. We're not going to go through all that. So in this case, it says chords A, B, and CD intersect inside the circle. Find the value of x. It's like the easiest formula ever. Do you guys see it? 20 times x, they're on the same chord, equals what times what? 16 times 5. Done. 16 times 5 is 80. So we end up getting x is equal to 4. Easy? All right, so let's try the next one. So in this case, we'd have 15 times x equals 10 times parentheses x plus 1. So we get 15x equals 10x plus 10. We subtract the 10x over, so we get 5x is equal to 10. So x is 2. So be careful, this says find CD. So what's CD equal to then?
30.
Nope. 17. Add them together, right? It's a length. All right, does it make sense? All right. So that's when they intersect inside the circle. Do we like that formula? Isn't it so easy?
Yes.
Just one piece times second piece equals, and then the other chord, two pieces multiplied together. All right, here's what gets a little bit harder. Okay, just like with the angles, we can have a tangent, right, intersecting with a secant, or we can have a secant intersecting with a secant, or we can have two tangents intersecting, okay? So we have lots of these pieces. So when I talk about these words, I'm going to talk about tangent segments. This right here is a tangent segment. I might talk about a secant segment. This is the part, so it says a segment that intersects a circle on 2 points with 1 point as the end point of the segment. So it's intersecting here and here. Do you guys see it? That's the secant segment, so the total. And then the external segment is the part of that secant segment that's outside. So this is the external segment. Okay, I'm not going to worry too much about it, but as we do this formula, it's going to be, this is a little tricky. Mrs. Summit Man used to teach geometry. Did you guys know that?
Wait, no, what?
Way back when she first started working here, she was hired as a math teacher. Even though she's totally the science guru, I know you guys know that. But she was hired as a math teacher, and it was Grandparents' Day, which we just had last week. And all the grandparents were in her room, and she goes, oh my God, I just taught something wrong, and told me, and she said, I'm in the circles chapter, and I said, let me guess, the tangents and the secant segments. And she goes, how did you know? And I was like, I did the same thing the first year I taught this. So this is a very easy one to mess up, because we just talked about this one, and it was so easy. It was like, x times y equals w times z, right? It was just those pieces. They were all multiplied together. And in this case, it is not like that. So don't be like myself or Mrs. Summit Man the first time you do this and mess it up. Okay, here's what it is. It's going to be this distance, which is e times a, or EA, I mean, not e times a, length EA, times the whole segment EB equals EC times the whole segment, which is ED. So in other words, I always say the outside part, meaning the external segment, times the whole equals outside times the whole. See how someone might confuse that and be like, oh, outside times that inner piece equals outside times the inner piece. It doesn't work that way. Don't do it that way. And so she didn't realize till the very end of her Grandparents' Day period that she was doing it wrong, and then had to tell all the students that she did it wrong. So we're not going to do that. We're going to do it right the first time. All right, so this next one is still outside times whole equals outside times whole. But here's where it's a little tricky. So I can definitely see the outside and the hole here. Can you guys see the outside and hole? So it's like EC times E times D. Or not E times D, I keep saying that. ED, the length ED. Do you guys see outside times hole? What do we think outside times hole is when we have a tangent segment? Outside is EA. Isn't that the whole thing too? Yes. Times itself. EA times EA. In other words, EA quantity squared, right? EA squared. You get it? All right, so that leads us to something. Oh, I didn't even draw it. What if I had a tangent-tangent? So one like this and one like this. Oh, geez. Terrible. So bad at drawing tangents. Are you guys bad at drawing tangents too? That's not even close to a tangent. It looks like it's crossing.
It just seems like it's drawing an ice cream cone.
It is drawing the ice cream cone theorem. So you could call this EA and EB. Do you see how EA multiplied by itself, EA, would be equal to EB times EB? Outside times hole equals outside times hole. In other words, EA squared equals EB squared. And Cam's saying, well, that's just the ice cream cone theorem, right? Do you guys remember what I called the ice cream cone theorem? That says if we have two tangent lines going to the same exterior points as tangent lines, those segments are going to be congruent. Yeah? All right, you guys are killing me here. All right, so you guys look like you're just bored to death. I'm trying up here.
Like yesterday, we're at.
Do I need to do like a song and dance up here or what?
No.
All right, you don't. I'm terrible. Anything involving rhythm. Cassie and I have talked about this. Anything involving rhythm, I am not talented at. Dancing, singing, it's terrible. All right, here we go. So find the value of x. Outside times hole equals outside times hole. Write an equation. Outside times hole. Crucial, you good? Equals outside times hole. What's the hole?
Oh, wait a minute. I did it wrong.
Did you do the Miss Summit Man thing? You did. Did you do 10 times x plus 1?
Yes.
I know, it's so tempting to do, isn't it? What's the hole? 10 plus x plus 1, which is 11 plus x, or x plus 11, right? Yeah. Makes sense? You're adding two segments together. So we get 144 equals 10x plus 110. We subtract the 110 from both sides. So we get 34 equals 10x. So x is equal to 3.4. That's our answer. So be careful. We have, remember, outside times hole equals outside times hole. Okay, let's try that on this one. Do we have outside times hole equals outside times hole? It's set up nicely for us, isn't it? X times 72 equals 40 times 78. Done. Well, not really done. 40 times 78 is 3,120. We divide by 72, and we get x equals 43.3 repeating. If you wanted to write it as a fraction, you could do math 1. It would be the same as 130 over 3. That works as well. Good? Yes.
Does it always have to be a number? Can it be a fraction? Or is it just based on what the instructions
It could be
say?
decimals or a fraction, doesn't matter. I mean, these are all numbers, right?
Okay. Well,
Ooh, look at this complicated drawing. How challenging. Okay, let's ignore. So imagine I'm covering these up right here. Ignore that part. Do you see how we have segments meeting on the inside of the circle? Do you remember how we did those?
14 plus 3.
Not 14 plus 3. 14
times
3 equals...
42.
No, well, I know it does equal 42. You're right, 42.
Equals 6x.
Equals 6 times x. So what's x? 7.
Oh, we got there.
So this is 7. Okay, now let's look at the outside times hole. So here's our secant segment and our tangent segment, right? I know, it's hard when they're overlapping. It's so frustrating, isn't it?
Wait,
You just have
is
to,
it-
like, look at the pieces that
Hold
you
on.
need.
I think I'm actually.
Oh, Cam thinks he's got it. What do we say?
It's 64 because 8 times 8 is.
Okay, I agree with that. So he's saying outside times whole. On the bottom part was 8 times 8, right? Do we see it? It's both the outside and the whole. Now we need outside times whole. Outside is y.
Times 7.
Nope.
Times 42.
Nope.
Oh gosh.
7's out. 42's out. What else? 13 plus y. I
Wait,
agree.
Where does the 13 come from?
What's 7 plus 6?
Oh.
This is 13 plus y. Do you guys see it? Because it's 7 plus 6 plus y. You guys are busy multiplying. 7 plus 6 plus y. Oh man, this is so challenging. Man, this one just makes you cry. 64 equals 13y plus y squared. So we have y squared plus 13y. Do you see why on your homework I had a little review of factoring? And you were like, why would you do this? Because of this section. I knew what was coming. All right, and we can try to factor. We started thinking of all the factors. We have 8 and 8. I don't know, we got 2 and 32. We got 16 and 4. Are any of these getting us 13 for the outer and inner terms?
No.
16 and 4 was close. So what do we do?
Those really annoying things.
You guys are all just groaning. Negative b plus or minus the square root of.
Oh, no.
Kill it with fire.
Oh my gosh. Guys, it's Tuesday. It's not even Friday. You guys are still struggling. All right.
Oh, I was struggling.
So we have negative 13 plus or minus the square root of 13 squared. 169. Did you guys know that? Minus 4. A is 1. C is negative 64. All over 2 times 1. First of all, do you guys remember this? Some of you guys were having trouble with this before. Colin, remember? A is 1, B is 13, C is negative 64, right? So we're not putting the y's in. We're just putting the coefficients.
Wait, where does the 1 come from?
Because it's like 1y squared, right?
Oh, yeah, that makes sense.
All right, and we continue. So we got negative 13 plus or minus the square root of. So we have 169 minus 4 times 1 times negative 64. We end up getting 1193 under there. All over 2. And if you try to take the square root of 1193, it doesn't work. Okay, you can try to reduce it down. I don't know about 1193. I don't know what goes into it. We'll just leave it as square root of 1193, or we could get the decimal versions. Do you guys like decimals?
No.
You like decimals. Yeah, what'd I do? $256 plus 1? 4 times 64 is 256 plus 1169. What did I do there? Oh, yeah. 425? Is it 425? Well, that's a lot nicer than 1193. Why did I get 1193? I know. Thank you. Yes, bonus point to Anvita. Look at my bonus points going on today. It's really a shame, isn't it?
I'm
Only
s-
Tuesday.
Tuesday and it's already.
I know. I usually said Tuesdays are my good day. Oh, you're just getting bad teachers. All right, so you can try to reduce it down. 425 does, that we could reduce that down. 425 divided by 25. Ugh, 425 divided by 25. How many quarters go into $4.25? 17 quarters. So we're going to have negative 3 plus or minus 5 root 17 all over 2. And one of those does not work. Because think about it. If you take negative 13 and you subtract 5 root 17, guys, think about it. Negative 13 minus something, and then divide by 2. Isn't that a negative number?
Yes.
Look at y. Is that going to be a negative number?
No.
No. So the only one that works is negative 13 plus 5 root 17 all over 2, which you can get as a decimal if you want. You just do negative 13 plus 5 root 17, hit enter, and then divide by 2. So like 3.808. You could use that. That's it. All right, that's the end of the chapter. Whoa, crazy.